In this lesson, we'll be learning about and practicing prime factorization, meeting the requirements for TEKS 67A. Before we go any further, let's make sure we understand some key words and phrases that will help us to better understand the lesson. So let's start with composite number. A composite number is any number which has factors in addition to the number 1 and itself. So for example, the number 10 would be a composite number because it does have the factors of 1 and itself, 1 and 10, but it also has the factors of 2 and 5. Since it has factors in addition to 1 and itself, 10 is a composite number. Now let's talk about prime numbers. Prime numbers are those numbers which have the factors of only 1 and itself. So for example, the number 2. The number 2 would be a prime number because its only factors are 1 and itself, the number 2. The number 5 would be a prime number because its factors are 1 and 5. If a number only has the factors of 1 and itself, that number is a prime number. Now, prime factorization. Prime factorization is when we break a number down, we decompose a number into the product of its prime numbers. And over the next few slides, I'll show you two methods that you can use in order to do prime factorization of any composite number. In the next few slides, I'll show you how we can do prime factorization of any composite number using a factor tree or upside-down division. Now remember, prime factorization is when we break a composite number down into a product of its prime factors. And the way we do that is by using either a factor tree or upside-down division. On this slide, I'll show you an example of how we use a factor tree to do prime factorization. Let's say we wanted to find the prime factorization of the number 100. Well, a tree has branches, right? So first, we draw two branches. And on those branches, we put two factors that, when multiplied, will make the number 100. So let's start with 10 times 10. 10 times 10 will make 100. At each of these numbers, I'm going to draw two more branches. And now I need to find factors that will make 10. And so 2 times 5 and 2 times 5. When my branches have prime numbers, and remember, the number 2 is a prime number because it has the factors of only 1 and 2. And in fact, the number 5 is also a prime number. It has the factors of only 1 and 5. When my branches end in prime numbers, I stop drawing branches. I circle those prime numbers. I then count them up. I have 1, 2, and I have a second 2. So I write 2 squared, 2 times 2. I have 1 5 and a second 5 times 5 squared, 5 times 5. The prime factorization of the number 100 written with exponents is 2 squared times 5 squared. 2 squared times 5 squared. And here's how this works. 2 squared, or 2 times 2, is 4, times 5 squared, or 5 times 5, 5 times 5 is 25. And we know that 4 times 25 is 100. The prime factorization of the number 100 using a factor tree involves branches until we have only prime factors remaining, which we then write using exponents, so 2 squared times 5 squared is the prime factorization of the number 100. Now let's try a second example using a factor tree. So if we wanted to find the prime factorization of the number 144, I start by drawing two branches. Now I believe that I could multiply 2 times 72. 2 times 72 would give me 144. Now the number 2 is a prime factor, so therefore we circle it and there'll be no more branches off of that number. Now I need to draw two branches off of 72. And which two factors, when multiplied, would form 72? I think we could do 6 and 12. 6 and 12 are still not prime numbers, so I can draw branches off of them. 2 times 3 will give me 6, and those are both prime. And let's see, 2 times 6 will give me 12. 2 is prime. I draw two more branches off of 6, and 2 times 3 gives me 6, and both of those are prime. And now I count up all of my 2's. 1, 2, 3, and 4. So 2 to the 4th power times, and I count up my 3's. 1, 2 times 3 squared. 2 to the 4th power times 3 squared is the prime factorization of the number 144. And we can show that 2 to the 4th power, or 2 times 2 times 2 times 2, 2 times 2 is 4, times 2 is 8, times 2 is 16, and 3 squared, or 3 times 3 times 3 is 9. 16 times 9 brings us right back to 144. Now, a second method you could choose to use to do prime factorization of a composite number is called upside-down division. Now, using the same numbers we used in our previous examples, let's start with the number 100. And this time, instead of drawing branches, I'm going to do upside-down division. And here's what we mean by that. You know that if we were doing a division problem, we would draw the house like this. Well, with upside-down division, all that means is we're going to draw the house like this instead, upside down. We're going to divide the number 100 by prime factors, starting with the smallest possible numbers first. So let's try 2. 100 divided by 2 is 50. Can we divide this by 2? Yes. 50 divided by 2 is 25. Now we can no longer divide by 2 because 2 will not go into 25 evenly. Can we try 3? Well, 3 won't go into 25 evenly either. But the first prime number that will is the number 5. 25 divided by 5 is 5. And now that all we have are prime factors, numbers that have the factors of 1 and themselves only, we're finished. We count up our 2's, and we have 2 of them, so 2 squared times, we count up our 5's, and we have 2 of those, times 5 squared. 2 squared times 5 squared is 100. 2 squared is 2 times 2, which is 4. 5 squared is 5 times 5, which is 25. And 4 times 25 is 100. We got the same result when we used upside-down division as we did when we used a factor tree. Both methods will work. You should practice both. In this case, upside-down division found the prime factorization of the number 100 was 2 squared times 5 squared. Again, let's try a second example. And once again, we'll use a number that we used earlier when we used a factor tree. We used 144. Upside-down division. starting with the smallest prime numbers we can. So let's try 2. 2 will go into 144 72 times. Let's try 2 again. 2 will go into 72 36 times. Let's keep trying 2. 2 will go into 36 18 times. 2 will go into 18 9 times. And now we can no longer use 2 because 2 cannot go evenly into 9. But the first prime number that can is the number 3. 9 divided by 3 is 3. And now all we have remaining are prime factors. We count up our 2's. 1, 2, 3, 4. So 2 to the 4th power times, let's count up our 3's. 1, 2. 3 squared. 2 to the 4th power times 3 squared is the prime factorization of the number 144. And we know that 2 times 2 times 2 times 2, or 2 times 2 is 4, times 2 is 8, times 2 is 16, times 3 times 3, and 3 times 3 is 9. 16 times 9 brings us right back to 144. The prime factorization of the composite number 144 is 2 to the 4th power times 3 squared. As we get ready to conclude the lesson, let's remind ourselves some key words and phrases required to understand this lesson. First, a composite number. Any number which has factors in addition to 1 and itself. A prime number, which only has the factors of 1 and itself. And prime factorization, which is the process we use to break a number down into the product of its prime factors. Earlier in the lesson, I showed you the 2 methods you can use to conduct prime factorization. The first method was the factor tree, where you drew branches off of composite numbers until those branches ended in prime numbers. And the second method was upside-down division, where you divided your composite number by the smallest possible prime number until you only had prime numbers. Now let's look at one more example of each before we finish the lesson. In a factor tree, we take our composite number, let's say we have the number 28. We draw branches. We find 2 factors that when multiplied will give us 28. And we draw branches only off of composite numbers. And so since the number 2 is prime, that ends that branch. And since the number 14 is composite, it has factors other than just 1 and 14. In fact, it has 2 and 7. The number 2 is prime, so that ends that branch. And the number 7 is also prime. I can only get 7 by multiplying the factors 1 and 7. Since all of my branches have ended, now I count up my 2's, which I have 2, 2 squared, and my 7's, which I only have 1, times 7. 2 squared times 7 is the prime factorization of the number 28. Now let's use that same number of 28 to do prime factorization using our other method of upside-down division. I divide 28 by its smallest possible prime number, and that would be 2. I know that 28 can be divided by 2, and that would give me 14. Now I know 14 can also be divided by 2, and that 14 divided by 2 would give me 7. The number 2 is prime, the number 2 is prime, and the number 7 is prime, so I'm finished. I count up my 2's, of which I have 2 of them, 2 squared, and my 7's, of which I have 1, so times 7. And 2 squared times 7 is the prime factorization of the number 28. 2 squared, or 2 times 2, would give me 4, and 4 times 7 would give me 28.